Welcome to day 14 of the advent of compiler optimizations. Yesterday we talked about loop invariant code motion and under some circumstances when it would fail, and we're going to look at some more of those today. Today we're going to write a little routine that checks whether a C-style string has an exclamation point in it, which, is much better done other ways, but we're going to say has pling. I would call this a pling. It's a very old British computery thing. So we're given a string, which is 0 terminated, and then we're going to say something like for stood size t index equals 0, index is less than strlen, stood strlen, trying to be good about this, len of str. Again, loop invariant code motion is what we're hoping for here. No one really should be writing code this way. We say if str of index is equal to exclamation point, return true. Otherwise, return false outside the loop. Let's just I reformatted it and now you can't see it. So let me manually format it back. Okay. It's apparently unhappy with me. Oh, that's right, because I need to tell it that it's a char star, of course. And I like my pointers to go with that. Anyway, we wrote some code. Let's have a look at what's going on the right-hand side. And if you remember what happened yesterday, you should have a pretty good understanding of what's going on. So, subtracting some stack space. We need to set up the stack if we're going to call under the function, which we are here. It's going to call strlen, and it's calling strlen outside of the loop. Hooray. It's noticed that strlen can't possibly change. We're then reading, having stored RDI, we get it back off of the stack. So we're just pushing and popping RDI effectively there. Then we are adding racks to RDI. So racks presumably is the return value of strlen. Yep. So we're now getting the end pointer. So racks now points to the end of the string. We're jumping to L2. We're saying, are we at the end of the string? If not, go to L1. L1 says increment RDI, so we're walking along the string and check the previous byte. Again, it loves to do this to see whether or not it is 33, and 33 we should hope is an exclamation point. It is, and if it is equal to an exclamation point, we go to L5 where we say mov eax, 1 restore the stack pointer back to where it needs to be and return. So that's the return 1 case if we found an exclamation mark. Otherwise, the L2 case, when we were looping round and round, will eventually fall off the end when we hit the end, the last byte of the string, and return. Fantastic. Fairly straightforward. Again, you should not write it this way. There's no way on earth that you shouldn't be using memchor, or we take a string view and use contains and all those kinds of things. But right now, we're just trying to show some cool things. The first thing is that the non-trivial, non-inlineable call to strlen has in fact been identified as something that can be moved outside of the loop. That's pretty cool. That's not always true. The strlen function internally is marked within the compiler as being pure and having only reading through the pointer that's passed to it. So the compiler knows what's going on inside that strlen function, even though it can't see into it and wasn't able to inline it. So what if we were to do something like we did yesterday, where we're going to use a counter of how many times we have done comparisons. So let's do total comparisons equals 0. And then within this loop here, every time we've done one of these comparisons, I'm going to say plus plus total comparisons. Now, if you remember what we said yesterday, aliasing, type-based aliasing means that the compiler can't assume that any pointer to something doesn't have something else pointing at it as well. But that only works if they're the same type. So at the moment we've got a size t up here that we're changing, and we're comparing a char star. So we should be good. This should do the same kind of optimization we saw yesterday. And rather unfortunately, several things have happened. So let's just quickly look again down our loop. We are always incrementing num comparisons directly in memory. We're not caching it in a register and then incrementing it and then writing it at the end, which you'd think it would be doing. And worse, suddenly we're now calling strlen inside the loop. So our loop from L4, for each iteration, we're calling string length again. Why? So why on earth is the compiler forced to do this strlen every iteration? Char and bytes are different. In order to sort of interact with operating system level routines like fread or malloc or other things like that, there is sort of a get out clause for the type-based aliasing that the compiler uses otherwise. What that means is every time you see a char star being either read or written to, the compiler has to assume that might alias with anything else. And as a result of that, it has to be very conservative. Every time we increment total comparisons, even though it's a size t, that size t may alias with the char star that was passed into this function. And so we have to assume that incrementing total comparisons might change the result of strlen. So yet again, aliasing is kind of rearing its head and having some unfortunate effects here. I guess the main thing really to take home from today is that reading and writing through char star is different and may have some performance implications for the compiler and the kind of optimizations it can perform for you. It's not all doom and gloom though. Most of the time, type-based aliasing saves us from all this kind of thing and the compiler is able to make some great optimizations as a result of it. Anyway, I hope you enjoyed this today. Tomorrow we're going to look at more aliasing, but then I promise we'll do something else. Hope to see you then. Bye-bye.